What Matthew and I have been working on together is really about trying to dispel the hype around the cloud from the point of view of what actually are people using it for and how can they actually make the most of it. And that sounds like a blindingly obvious thing to say, but a lot of it actually boils down to physics, because one of the things that we kind of forget as technologists is it's not so much about software can just do everything, and you just need a bit of orchestration, or you just need a bit of dynamic management, or something clever written by someone, or some clever box. But you actually need to think about what's going on underneath the surface, which is about getting your storage in the right place, it's about getting your service in the right place, and a lot of that boils down to making sure that you're making the best use of the network. So Matthew works for Interoute. I'm kind of going to ask him this question, although I kind of know the answer myself, but I want you to know the answer, which is, what gives you the right, Matthew, to even be discussing this topic? So, over to you.
Yeah, I'll give a very short introduction to who Interoute are. Interoute is Europe's largest infrastructure provider. By that I mean we have more kilometers of lit fiber and square feet of data centers than everybody else. Why do we do that? Because we are the largest carrier's carrier, that's what we do. And we kind of have three ways of selling things to people. We call it from ground to cloud, it's very simple. We do facilities, so it's literally cables, and we'll do those for 25 years for you. We do platforms, that's a big voice interconnect platform, cloud communications these days, obviously big layer 3, MPLS infrastructure, and then our virtual data center. Then on top of that, we then piecemeal that down to individual components. So one of the key things for us is we started an architectural journey 10 years ago, more than 10 years ago, to really build a sort of platform, and progressively as technology allowed, as the development of APIs allowed us, frankly, allow us to really parcel down access to this platform down to what you see today, where you can sign up for an hour as you would expect from any public cloud computing type platform. Uniquely, what we've also done is we've automated the network, and that gives us a perspective to work with that. And I think, to Jon's point, why we qualified to kind of comment on this is because we've been doing it for around 10 years. And what's somewhat disappointing as a technologist is I first started in the world of voice over IP, actually before that,
it's
in
semiconductors.
The future,
I'm telling you.
And in 1996, right, which was a bit depressing, we said, you know what, you can talk for free over the internet. Skype said you can talk for less, and they made a little bit more money than we did. But the point being is it takes an awfully long time for people to adopt. So I think one of the things we've seen is just seeing this continual migration from people. From 10 years ago, we had 3 or 4 different types of network, we have 2. 10 years ago we had, phones. Now we have smartphones. So we've watched this transition, and we've watched it really from a sort of architectural out perspective, and that's kind of where we're coming from.
So what kinds of, this cloud thing, right? You can do anything with it, can't you? So big research projects, you can stick loads of data in it, you can analyze it, sentiment analysis, you can do all sorts of clever things. What kinds of things are your customers actually using it for?
Well, I think we've got, to your point, we've got the extreme. Interoute serves the European scientific community, so the European Space Agency. So we do a network which stretches from north of Alaska down to South America for the satellite pickups. And they process every 3 days the Earth observation satellite data. So they bring up a whole bunch of servers, all automated, all API driven, and then they publish that on their websites and sell it out to the scientific community. And I think the thing that has always struck us is that same platform is used by folks like a company we have in Belgium who make dental implants. And all they do there is allow them just to make things a bit easier. So to consolidate their data centers and move things on net. The key thing for us at an infrastructure level, when people talk about the cloud, is to really think about, when you're architecting it, is to think, what I'm doing here is I've got computing processing capability, and then I've got a bunch of relationships, and that relationships are defined by obviously a network, be it the internet or be it some other structured relationship, and try and keep your architecturing and how you're thinking about it in that kind of simple level, because you'll get the benefit, and we've received the benefit, you get the benefit from silicon integration continually. That continually comes. The challenge is always to reap that benefit and not find yourself suddenly becoming too prescriptive. So we're quite pure in the way we think about ourselves. We're not going to pretend we understand people's business processes or any of this kind of stuff. We are, our ambition is really just to say it's a very large distributed compute and network platform that you can program.
I mean, so you can do all that, right? But I think one of the getting to this physical virtual thing, there's some pretty hard constraints going on. And I know that something that Matthew and I have been talking about quite a lot is the difference between the core and the edge. So I can either say, hey Matthew, tell me the difference between the core and the edge, or I can say, well, the difference between the core and the edge is. But I think what's very important about what you've already said is, yes, sure, you can do things for the European Space Agency and it can be all big and sexy and make great case studies, but equally, it's just as applicable to people whose needs are a bit more mundane in migration projects, in just down to earth, making things simpler and easier.
But to your earlier point, it is physics, and this is the key thing. It's physics and economics. Skip, the technology side. It's physics and economics. The world is defined by geography. We can't do anything about that. The speed by which you can distribute stuff around that world is defined by the speed of light. We can't do anything about that, right? There are folks in CERN who are probably trying to nudge it a little bit, but we can't do anything about that.
What, speed of light? So
yeah, speed of light. We haven't
nudge it a little bit.
Given it a nudge. And the speed at which you put stuff onto that speed of light carrier, fastest we can do it at the moment is 100 gig. The other thing to bear in mind is economics, right? And the most practical way of thinking about economics is, I thought about this morning, someone asked me about it. I said, if you're running a bed and breakfast, right, and you're on an island, and your shop is on the mainland, right, and someone comes in and says, I don't like white bread, I want brown bread, and you haven't got any, you're going to say, well, that's tomorrow, mate, because the boat goes tomorrow and I'll go and get it. If you're in a town, and the convenience store is below your bed and breakfast, you can whip out and say, yeah, I can have that, I can have bagels, I can do whatever they've got in Tesco's downstairs. The point being is if you're architecting a corporate environment and you're not putting your assets in a central location so you can distribute them, in the same way that drive up the M1 in the UK and you get to the junction with the M6 and it's littered with huge logistics centres, right? Because they're moving, and drive down to deepest, darkest Cornwall and you won't see them. You'll see a big dairy in Davidstone, right? They make cheese. So it's a different architecture. What you've got to bear in mind is if you take stuff off the network, it's going to go slower. It's also going to be a lot more expensive because the cost of access at a technology level is irrelevant. That moment where we used to think about cost of access based on capital disappeared about 5 or 6 years ago. It's cost of labor. And that doesn't go down. It either stays the same or goes up. So it doesn't matter what you do, right? Why is my 1 meg connection or my 10 meg connection, right, so much more expensive per meg than the 10 gig connection I can buy on net from someone like an Interoute or someone else like us? Reason being is that's labor, and the other one is capital cost, right? The other one is driven by the cost of silicon, which gets cheaper and cheaper and cheaper, Moore's law, which is still with us at least for the next 10 years or so, hopefully. And the other one is driven by the cost of labor. So if you're optimizing how you're distributing things, skip architecting the cloud for a minute, right? If you're optimizing how you're distributing things, put it somewhere where it's going to be more cost effective.
It's, just by the way, I just found out over the weekend that the A1 exists because of horse trading. I didn't know that. Did everyone know that? Hands up who knew that already. So, there you go, so you learned something even more. But it's all about that, isn't it? It's sort of, that was where all the horses were. Yeah. So that's where that's why those towns became those towns, because that's where the horses were. And so it wouldn't make any sense stabling your horses 50 miles away, because that's not where the horses are. It's one of those very simple things. And as I say, we need to remember that the internet is all big and clever, and we draw clever architecture pictures, but actually it is all about very physical constraints.
And the other thing to bear in mind, just on the internet, the one thing you should think about, people say about cloud computing and where is it going to go, it is kind of obvious, right? Well, what happened with networks? 10 years ago with networks, or 10 years ago with communications, it was a very physical relationship. When you made a phone call, you were creating a not quite physical, but a very defined, logical relationship between you and the other guy, right? That relationship broke about 5 or 6 years ago, whereby your phone call started to route itself, right? And you didn't care what the underlying infrastructure works. That's how our smartphones works. That's why it works over wireless. That's why it works over mobile. We don't actually care because we've separated out. And one of the things to bear in mind with cloud computing, when we think about it, when we think about the cloud, is that separation. That separation allows for interesting things to start to happen. So when you are architecting the cloud, in the same way, when people first built networks, when they had TCP/IP, don't think of it like an SDH guy or an old-fashioned network guy, right? Because it doesn't behave the same way. It does different things. It's trains and roads. It can go where it wants to. So, for example, we often, when people talk about architecting clouds, they talk about, well, how do I do disaster recovery? Well, disaster recovery is a physical, kind of static kind of relationship that you've built up because you had a real data center with a real connection to something here. What you should be thinking is disaster reversion. And that means architect active-active, architect multiple sites. And ultimately, and this is one of the research areas that's the most interesting, is mobility of the actual workload itself. And that's what the folks in the SDN world are thinking about, that's what the folks in the orchestration world are thinking about, is how do I make that workload mobile? And once you have mobility of workload, or you can do it at an application level, you're into a world a bit like the internet. The internet doesn't actually fail. Why? Because it's 305 some odd thousand AS relationships, which are so many and so dense, that even if the likes of Level 3 and Interoute and Cogent all decided to stop exchanging traffic with each other, it'll still carry on. It might slow down in some parts, but it'll still carry on, right? Because it's too big, there's too many relationships. And one of the key things about architecting the cloud, and when you're thinking about a cloud computing environment, is you should expect higher performance. Why? Because the physics of it should be closer to you, right? Or it should at least be near. It should also be higher availability, because you have that option. You have that option to create multiple relationships now in a far more agile way than you can in the physical world. So it is that adaptation that people need to think
about. So from, okay, here I am, medium, large size organization. I'm thinking, yeah, okay, cloud. I'd like to shift some of my stuff off, and get it over there. Yeah. Sounds good to me. What on earth do I do? I mean, should I be thinking about the data? Should I be thinking about services, service level? Should I be thinking about where people are and where they're trying to access it? Should I be thinking about the MPLS bandwidth? All of it? Any of it? What order?
I think you've got to start with where you think your organization is. And the simplest way to assume these days, what I see with customers, is they're all over the shop, right? The buggers have left the office, right? Most of them are on, I don't know if we've got any IT managers in the room. But
have we got any IT managers in the room?
How many IT? So most are used to. I used to hate this. Many years ago, there was an advert. I used to live in the States, and this is the late '90s, by the way. And MCI had an advert of a guy video conferencing on the beach, right? And we'd just done video conferencing over IP. And you'd walk into an account, and they go, "Can I do the thing that MCI do?" And you'd go, "No, you can't. It doesn't work. It's a future." And I think one of the challenges we always see with the sort of, I wouldn't say a battle, but the relationship between IT managers and their audience is the sort of kind of gay abandon of the consumer, right, in what he can do and what he can get away with. And what is practical from things like an audit perspective, what is practical from a data sovereignty perspective and a data compliance perspective. We've got a very large audit customer. They do auditing globally. And the IT director of their central cluster once joked with me. He said, well, the partners have come back from Florida. They're going to spend $60 million on tablets. And I said, oh, that's interesting. He goes, and then I've told them it's going to cost $50 million to secure them all, right? And he chuckled to himself in that slightly dark, humoured way. The point being is, it is about, you assume your community is going to be mobile. You assume they're going to be unreasonable in their level of demand for data, right? And what you've got to do, what we've seen, is data consolidation is a key thing. Get it in the right place. Get it in the place you want it. And then progressively, what most of our customers do is establish a base and then slowly start to move things over, right? It's a kind of slow, soft migration. One of the great things about these kind of architectures is you don't have to do the shut it down, leg it across town in the back of a van, stand it up and hope it works model. You can start to soft migrate things. We have a lot of customers who are simply doing nothing more than shutting down co-location racks one at a time, right? And it's from a customer perspective, they're not seeing anything radical, i.e. their users. What's just happening is they're just shutting down these racks and bringing them up in a virtual sense. So I think it's the data. You assume everybody's everywhere, and it's establish a platform by which you can just soft migrate.
Right, so we've got, essentially, you want to reach as far as you possibly can and have low limits on reach, and in order to achieve that, you want to pull your data into the middle as best you can so that it can get out there.
We say make yourself look like a service provider, right? Because the most successful, if you think about it, the most successful companies in the world of the last 10 years are the likes of Facebook, Amazon as a retailer, Google, et cetera, they're service providers. They think, I can tell you at a supplier level, the likes of Google, Microsoft buy exactly the same way as the big global telecom operators like AT&T and Verizon and Sprint, right? It's the same thing. What they do with it is different, grant you that, but what they're doing is the same. So one of the things we would always say, and I'm sure everyone in the audience goes, I bet you would say that, right? Is don't build your own cloud, right? It is universally, unless you're really, really interested in it, right? But it's universally not useful, right? Because all you're going to do is, it is, I hate to use the iceberg example, but it is, what you're doing is you're creating an infrastructure and then you're going to use it. The real opportunity now is to try one that fits, right? You've got to have, if you're in an enterprise world, try one that can give you a decent security story or give you a decent private cloud type story. But then really move on. The opportunity here
this is psychology, isn't it, almost? Yeah. How many people are building their own cloud because they don't trust the big cloud out there? There you go, at least one.
Oh, no!
So but, it's don't start me off about hybrid, by the way. We'd be here all day. And if anyone's got any questions, by the way, just raise your hand, because we do have a roving mic. Any questions? Because we'll shut up for a second, just in case, in which case I'll ramble on again. But essentially, what we've seen over the past 5 years is people of this ilk saying, cloud, fantastic. 5 years later, suddenly, well, about 2 years ago, everyone would say, well, okay, maybe we could work with a hybrid kind of thing. Let's negotiate, let's tackle that. But actually what you're saying is that's kind of, it's an interim step too far. It's an unnecessary interim step, but it's psychology,
hybrid is not hybrid as defined by our folks in the orchestration world, the Citrix, the VMwares, the OpenStack. That is buy one here and buy one there, right? It's the old PBX model, right? If you want the features on the PBX, you've got to buy it everywhere, right? I would do the same if I was flogging orchestration. It's a good idea. All our customers live in a hybrid world, right? And they use things like subnets to build those relationships. Subnets are not particularly sexy, they're well understood, but they kind of work. You're always going to have, like, we've got a customer who's got a piece of storage he would love to get rid of, but he spent a lot of money on it, and it's got a couple of years to go. So he's going to roll that in. So everything is always going to be hybrid. And it's going to take a number of years before you've got the dodgy application that someone bought for payroll, and God knows how it works, and you can't port it to anything, so you just want to have it there. What you've got to do is, that's what I mean by build your platform, right? And build a platform using well-known, understood technologies, ones that come out of places like the IEEE and the IETF, not some, I would say, alternative consortium. Just build a platform that allows you get visibility at a network level, because that's how you connect stuff.
Was that a cloud stack question there?
No, no. And then you can migrate. Once you've got it all, you can migrate.
So, we have a question. So
Jon, you said that you asked people who were building their own clouds, only one person raised their hand. I'd like 2 other questions asked. How many people are actually putting their own product, or their own services in the cloud, or already have done so?
Okay.
And if they are, how have they done it if they haven't built their own?
Okay, so the question was, another show of hands really, how many people are using the cloud in anger, I guess would be a good way of phrasing it, to put their own products and services out there in the cloud? And how many people are thinking, so another little show of hands thing, how many people are thinking of building their own internal cloud but they're not doing it yet? And how many people are actually thinking of sticking some of their stuff, even migrating some of their stuff out into the cloud but are not actually doing it yet?
Can I ask a follow-up question? How many people define the cloud as the public cloud accessible by the internet only?
One.
So it's simply, you wouldn't use an external data center. You would want to build it in, you want to own the infrastructure yourself. Is that the majority are saying?
Is that requiring a response? So,
No, I was just saying.
Yeah,
it's an
rhetorical
observation.
point there.
It's a rhetorical point.
I mean, I think just judging by the show of hands, because it was different hands going up every time, that is the morass that we're in at the moment. There isn't one answer, and even though there might be one answer in one person's head, and some of these things, back to what we were talking about at the beginning and right the way through, there are some logical reasons around physics that cause one answer to be preferable, and economics, than other answers. But then equally, we've got a lot of heritage equipment. What's the phrase now?
Legacy.
It's not legacy. No, that's the old one. It's technical debt, I think. Yeah, technology debt, I think, is a great one. That's a utilities company I'm talking to at the moment said, yeah, it's the technology debt that's causing us the problems. So who's got technology debt? Who's technology overdrawn? So, but one of the fascinating things was who believes that they're actually maintaining stuff without actually knowing if it's still useful, because they're not sure about how to evaluate whether or not it's useful, and therefore you better carry on because it might be useful at some point in the future? Okay, not that many. All right, it was a big question, small answer, sorry. But that's where we are at the moment, isn't it? But ultimately, there are ways of building things that do base on Moore's law, do base on geography, on economics, etc., and we've got to work out how to get there. But I mean, ultimately, do we require a mindset change?
I think I don't think you need a mindset. I think having a mindset change out of some moment where you suddenly go, my God, I get it. I've walked through this fine hall here, and this guy told me it, and I've seen the light. You don't need to go down that road,
Cloud
right?
epiphany.
Your cloud epiphany. All you need to do is try it and give it a whirl. That's what you need to do, is try it out and see how it works. The wonderful thing about this, which is different from all the other stuff, is you'll still be seeing out on this floor out here, and you'll hear from the way you bought computing in the past, is you can try it yourself. Just try it and see what it works. See if it works, and you can. It's a Friday afternoon project. Give it a go. See what happens, and you go. Because that's how a lot of it starts. People go, my God, it's fast. Right?
I know one organization that have built something that they call the purple cloud, because it's not as scary as the real cloud, but then they can test out how to use it. So it's not so much a question of whether to use it, it's just trying to work out the ramifications of how to use it.
And I think a lot of the traditional concerns are transitory, right? Because, sorry, there's a question coming.
And then we are on time, so one last question, sir. Well spotted. Otherwise, Joe will be hitting us around the head.
I was just curious how SDN fits into the overall approach.
SDN? So the software-defined networking.
Well, SDN is, we went down the network virtualization route about 18 months ago out of necessity, because if you're going to insert computing into networks and you want to have a real-time utility-based model, you can't have it that I've inserted it into the network and, oh, by the way, it's going to take 6 weeks for some provisioning guy to then give you the network. So we automated the creation of the MPLS VPN or the VRF and the public address space. In terms of SDN for us, SDN, depends how you want to view it. If you view it as a, software policy control and how you're thinking about your network, understand something. The reason we have network routers is because we're doing very, very fast packet inspection, right? And your good old Intel x86 CPU can't do that, right? It didn't have the oomph to do it at speeds, for example, with it rerunning the backbone. That is the basic architectural tenet of all service providers, right? If we could use an x86 or an AMD, right, to do the whole lot, right? And it's, you've heard the stories about generic hardware, et cetera, et cetera. That's the silicon cost curve we're all driving down. We have to use specific hardware acceleration for certain things, networks being one of them. Software-defined networking is about separating out policy control from the data stream itself, right? And I think the way to think about that is, yes, you can get wrapped up in a lot of the hype, you can get wrapped up in what a lot of people are saying, but we run virtual routing instances on our virtual data center, which is then talking to the MPLS infrastructure, which is connected to a CPE, which is a regular Cisco router CPE, which is then bringing services in. And that works great as an access service. Have we done it in the core yet? No. Why? Well, we don't actually need to. But fundamentally, will it happen? Yes, it will. And why do we know it happened? Because it's happened to everything else. Voice networks run in exactly the same way. Mm-hmm. They have separation. They have things called policy servers, and we have about 6 or 7 of them. And then we have hundreds and hundreds of what they're called session border controllers, and they are taking the data flows. So data and policy separation is a great thing. Architecturally, it's how you want to do things. What stops you doing it is the nature of the media flow that you're dealing with. So in SDN, it's packets.
It's yet another migration, though, isn't it?
But it's just progression. It's going to happen, and you'll see it. You'll see it at the edge now. You'll see folks doing what they call virtual CPEs.
So watch that space, I think, is the answer. And with that, we're out of time. So thank you very much, and thank you, Matthew.
Thanks, Jon.
And thanks for your questions. Cheers.